Hello everyone. Today we are going to start a new project on water detection from the satellite by using unit and image segmentation in the deep learning and machine learning. Okay, this is the image of the water surface taken from the satellite view. Okay, before this I will show you how we built an application for this model so you can come to know our application how it works. Okay, this is the application homepage, so you can come to know that our application how it works. This is the homepage for our application. Inside this, welcome to the ROI segmentation. This application uses advanced segmentation techniques to identify regions of interested in your images. Start by uploading an image. So by click go to upload page. So by clicking on go to upload page, it will open the next page. Yeah, okay, yes, it's open. Upload an image for segmentation. Select Please select an image to process with our segmentation model. Choose an file. Okay, let's choose the file. Yes, take one image of the water. Okay, I am checking this. Okay, okay, it took. Okay, upload and proceed. Next, it will give the result of this. Okay, it's uploading. It's taking time. Okay, it's got. Yeah, we got the result. Segmentation output. Input image as we uploaded the image. Now predicted mask like this and overlapped image. Okay, see this. Okay, this is the our application for this model. Now coming to the explanation part, we took one research paper for this model. That is, I will show you how it look like this way. Detection of surface water from satellite imagery using deep learning with indirect proxy based label collection method. Okay, this is the research paper for this model. See this inside content of this research paper. Everything I will explain by keeping mind in this research paper. Okay, let's brief on this explanation of this. Okay, importance of water detection from satellite. See this, monitoring water resources. Satellite based water detection enables the continuous and large scale monitoring of lakes, rivers, assessing seasonable water availability, tracking changes in surface water level over time, supporting sustainable water resources management. Second one, flood detection and management. Satellite can quickly identify flood regions in near real time, even in inaccessible areas. Benefits of this: early warning system for communities, guiding evacuation plans, post flood damage assessment. Third, drought assessment. By detecting the reduction in surface water bodies, satellite imagery helps monitoring drought severity. Application for this, supporting farmers with irrigations planning, activating drought relief measures in time. Environment protection. Water detection from satellite helps identify wetland degradation, illegal enhancements, and pollutions. Conservation of biodiversity, prevention of habitat loss for aquatic species. Climate change studies. Long-term water bodies absorbs Observations reveals how climate changes affects hydrological cycles. Examples impacts shrinking, shrinking glaciers and snow-fed lakes, altered river from altered river flow patterns, disaster response and relief. During tsunami, cyclones, and hurricanes, satellite helps map inundated, in, map inundated zones, allocated rescue and relief resources efficiently. Urban planning and infrastructure development. Water detection data assessed in designing drainage system, avoiding construction in flood-prone zones, planning water supply networks. Agriculture application from this ensuring adequate water availability for irrigation, monitoring irrigation efficiency, supporting precious for farming techniques. Okay. Now coming to the research papers, which was I have already shown you. Inside this, I took some important points and I will highlight that points. Okay, dataset they used source Sentinel-1 4 bands and Sentinel-2 13 bands. Satellite imagery total 17 spectral bands. Study areas Mid Napar, West Bengal, India. Resolutions each pixel contains 10 into 10 into 10 millimeter spatially resolution 10 to 16 meter depending on band size trending set nearly 50K records 15K water class 35K non-water separated test set 3K records labeling methods indi- indirect proxy based detecting visible water bodies view Google Maps coordinates. Okay, models architecture deep neural network that is DNN with 5 layers model to more complex versus 4 layers model. Layers dense and batch normalization. Leaky RELU dropout to avoid overfitting. Output sigmoid activation binary classification that's water versus non-water. Parameters they use model 2 has 21,781 trainable parameters. Now coming to the classification inside this research paper task binary classification detect water positive class versus non-water negative class. Matrix use accuracy, precision, recall, F1 score, confusion matrix that is TP, FP, TN, FN. Okay, confusion matrix example test set. TP that is TP that is precision. Okay, 1465 FE that is 213 FN 76 TN 1389. Now coming to the preposition approaches. Use of proxy labeling, avoiding expensive ground data collection, combined use of Sentinel-1 radar all-weather plus Sentinel-2 optimal multispectral for better accuracy. Scaling input to -1 to 1 for faster DNN training. Compare simpler model 1 versus complex model 2 network for performance versus data size. Now coming to the accuracy they got best accuracy is 88 near 88 to 90%. Model 2 slightly better overall. Example scores model 2 scores at 50K records accuracy of 0.88, precision of 0.81, recall of 0.98. Model 1 50K records in accuracy of 0.90 with precision of 0.85, recall of 0.94. Observations more training data improves generalization. FP cases occurs due to irrigation fields. Now coming to the proposed system, deployable deep learning based surface water detection system uses satellite data proxy labeling for large scale water monitoring without physical surveys. Work across varying geographical regions and seasonable. can be extended to compare historical versus present imaginary for change detection in water bodies. These are the some key highlights from the research papers which we took this, which already I shown this. This is the research paper. Inside that, I explained everything, some important highlights. Okay, and this research paper look like this. Introduction. They have given materials and methods they use, study of area. See this, and this is the table of this satellite parameters and satellite 1, satellite 2, which I have already explained. Number of bonds 4 and number of 13. Wavelength, spatial resolution, everything they have given. Data preparation, they prepared the data. Indirect proxy based, like already I have given, I have explained. Deep neural network model architecture, DNN. See this. Okay, and result and discussion. This is the result and resolution, result and discussion. Model prediction, actual prediction, positive and negative. Positive and negative, 1465 that is TP and 213 that is FP. Negative is 76 FP and 1389 TP, TN. Already I have explained you. This is the table. Table 1, records and accuracy, precision, recall, accuracy, precision, recall. Model 2, model 1, model 2, everything is they have given. For 1000 records, accuracy they got 0.88 and precision they got 0.81 and recall of 98, 0.98. Model 2, 0.90 accuracy, 0.87 precision, 0.92 recall. Like this they have got it. Okay. This is the accuracy table versus data size. Accuracy and versus data size. This graph. Okay. Now coming to the conclusion part also they have given, and acknowledgement I have also they have reference also given. Okay. Now coming to the our model, how we built a model, I will explain everything. This is the code for the our model. Inside this we did and we trained in 20 foxes. So first earlier we got an result of a loss of 0.3178, accuracy of 0.7393 and validate loss of 0.3020, validate accuracy of 0.7345. First we got, and the final result we got an uh, 20th epochs we got loss of 0.2232, accuracy of 0.7696, validate loss of 0.2432, validate accuracy of 0.755. Means we did only 20 boxes for demo purpose. For executing for better result we have to execute up to 500 boxes, then we will get accuracy of 95 or 19 above 90 above accuracy we will get. Okay, for demo process we did only for 20 boxes, so you got this much 75 percentage. Okay, if you need you will train up to 500 epoxes, then we will get the better result. Okay, these are the input image and predicted mask and predicted ground mask. Okay, everything. Now coming to the image application model. This is the application I have already explained you. Let's say we choose an image, another one image, and we will finish it up. Let's choose process another image. Okay, let's choose the file. I have already explained it earlier only. Okay, let's see, choose this one. Okay, open it. It will select. Okay, now upload and process. For this upload for this application we did background model is running it. Okay, see this code is running, it will uploading, it will take okay, see the result we got. Segmentation output in input image as like this and predicted mask like this and overlapped image like this. Okay, how we built application, everything I explained you guys. If you need any help regarding this model, we can help you. And also please contact us through YouTube channel. Okay, we have provided a contact number also. Guys, please share, like, and subscribe our channel. Okay, thank you guys by watching my video.